So how to basically make a pressure wound tank with AddPath. And I have set up here basically a cylindrical tank that you would see. It could be a mandrel, it could be a liner. Okay, so how would you get started? So you would go here, which is where you would go and try to add a mandrel. So you can import like a step file of the liner. In this case, I have the pressure vessel, I call it whatever. So yeah, as you can see, in the similar fashion, I imported it. So I already pre-imported it just for the sake of keeping the time short, and oriented it. So I'll talk about how I went about orienting it. So I imported the file that you can see is highlighted in red here. And then I went about picking up the reference for this particular file. So that is what I have chosen at this phase of the tank. So I picked up it here. I can actually go about doing it again. So you would go, yeah. I selected the origin and now start of the x-axis, clicking again. That is defining my x-axis direction. Starting of the y-axis again, and now ending of the y-axis. Okay, so now I have the mold reference created here, and I have created a custom axis that is oriented on my flange here. That is basically defining the central position of the flange and the orientation of this flange with respect to robot base. And with respect to that, I have oriented my tank at 250 millimeter away from it. And after picking up the mold, selecting it and aligning it with respect to my reference, I linked it to the external axis 1, which is in this case my rotary axis. Then I go about selecting the geometry. So in this case, I want to wind the area, and then I would go about selecting the boundary areas, which are highlighted in purple, sky blue. Yeah. And from the drop-down menu on the top, I would select what type of winding I want to do. So there are many options available. In this case, I wanted to do complete tank winding with domes. So I'm selecting continuous winding, tank with domes. We'll talk about also other options that are here in the other demo that I will talk through. Once I select this, what it does, it opens a winding UI here. So I'll go to that later. So here I have defined that I want to put down 1-inch white tape, which is 0.29 millimeter in thickness. I'm going to place it at 45-degree angle. Yeah, so I think once I have defined, like I want to do 45-degree angle winding, now I have to define and make sure that my reference for 0 and 90 is defined here. I think I missed that step, so I'll just quickly go back to it. It's a very critical step. So I need to make sure that I have defined my 0 degree at the beginning of the dome point, that is here. And then the dome beginning is here. So this circle center is what is defining my origin point. My 0 direction is aligned with dome to dome center, and 90 degree could be has to be perpendicular to that. Yeah, so this is very, very critical. So once, as is shown here in the diagram, with the dome, it is aligned, I'm able to start, and I need to get the D1, which is the diameter on the left side, sorry, D_L. So I would go and measure it. I'll show it here. So I'm going to pick up the point here and here. And now I have the measurement for that. And I need to do the measurement of the length again. Here I have known this value. I can also do just a measurement. And then similarly, I would go about, I can actually do the measurement. So let's go about that. Let's see if I'm able to do the measurement. Maybe not very well here. Here I'm able to select the center. Here I have some trouble selecting the center. But let's assume at the moment I'm able to select the center here, and I'm measuring the distance from this center to this center point. It's very critical that I'm measuring the starting of the dome to end of the dome, the length that I need to know. Then I have the middle section diameter that I can measure with just going to the diametrically opposite points, and then it measures it automatically. The length, once again, I'm able to measure center to center. And then the similar way, I would be able to measure the diameter here and the length here of the section, which in this case, because it's symmetric, I know. To start with, I'm just going to start with one circuit. If you want it to be completely covered, you would just put 0 circuits, and it will complete the complete coverage, and it will tell you all the values of coverage percentage, everything included. I think to start with, it's better to do maybe more than one circuit. We can do 2 circuits to see. Now we come here and we go about planning it. And now it will start planning. So you can actually see here on the top, as it starts to progress, it will do all the calculation. You would be able to see the angles, the range of these angles. And now you see the path that it has planned start to appear. It is also telling you in what angle bounds it is able to maintain the 45-degree angle that we suggested it to maintain. And it is a pattern type 2. And as we speak, it's also already started to plan the frames for the robot on this. As this is happening, I think one of the things to note is that you can see the mold here. It's actually not perfectly aligned ever. So there is a trick to see a very good simulation that I'll show in AddPath that would really give a very good visualization that does not look, it's a broken. So we are very close to seeing the tape 1 complete. Here, once again, I've gone for finer, how would I say, frame distance.
Could you explain what the frames mean and why they're important for the robot?
Yeah. So I think it's a very good point, James. Thanks. So the frames are basically asking the robot to be perpendicular to the surface and making sure that the robot aligns the tool's forward direction with the tape's forward direction. So if you have these frames correctly planned, then your robot would come to that particular place and move in that direction. That basically ensures that you would have the placement of the tape in the right direction. And you can manipulate each of these frames. So let's say in certain section, if these frames are in a way that your robot will hit something, you can actually go and change this set of frames that basically tells the robot to tilt in certain way to avoid an obstacle. So it allows you a very high degree of customization for this program that you create. Yeah, I think we are almost close to done here. Let's see as the visualization pop up. Now we see the tapes. So now once we go here, what we would be able to see is very nice simulation. So let's go refresh all frames. And I set this home position to begin with. So if I say go home, so this was as a starting point that I set up at the beginning. Okay, so now as we start to play this out, let's go at a faster speed. I'm not sure how choppy is the stream, to be honest. So are you able to see?
Yeah, the stream quality is not great while presenting. So we'll send a recording of this directly from Rhino that you can see.
Yeah, and as I said, like all of the files that you see here would also be available to basically play around with by yourself. So I think you should also just play around with the file for your own winding projects. So I will just go slightly faster, and that's kind of where AddPath is really good because you just have a slider that allows you to just move past this. So here, what I'm already able to see is that the winding looks fine, and I have the control pretty much of, I'm able to do continuous winding now with the AddPath.
And sorry to interrupt, for anyone who's not familiar with AddPath, the reason that there's like a yellow one and the black one is that the yellow one is the tape that is currently being placed, and the colored ones have been previously placed.
Yeah.
And so you're able to see exactly what the tool is doing. It's just another level of visualization that we provide on AddPath.
Yeah, and in continuous winding such as this, it's not like there are two separate tapes. It's just divided into circuit. So one circuit that has been previously placed, and the current circuit that, as James mentioned, is highlighted in yellow that the tool is now placing. Yeah. So as this is done, this is basically, I would say, if we would have put 0 and different angle, we would see definitely different simulations. And that kind of concludes the first part of what I would call doing filament winding with AddPath.